Hey, this is Mr. Aiden. I'm back and better than ever. This is Unit 8, Applications of Integration. We're going to be taking a look at the horizontal area between the curves. Now, we were taking a look at the vertical area between the curves, and that is where we had a function. Let's say we have a function right here, and we have intervals a to b, and we have a function, our f of x is up here, and our g of x is down here. And how do we find the integral of that? The area between here and here. We took a look from a to b of f of x minus g of x dx. Now, that was kind of the vertical. We had our x limits of integration on our x-axis, and we were taking a look at the top function minus the bottom function. Well, we're going to be doing the same thing, but sometimes it's easier doing the horizontal area, the horizontal integration, because here, take a look. I'm trying to take a look at the area in between these two curves. And if you can see, we have kind of a weird value. We would have this value up here with his area, then this value right here. I would have to add them together. But do you see how it's maybe easier to just do the area this way, with taking a bunch of what we would call Riemann sums coming this way? And so we're kind of taking a look at my area horizontally. And so I'm taking a look at all of these Riemann sums, or to an infinite amount, going horizontally. And so in order to do this horizontally, I'm dealing with my limits of integration all the way from e squared all the way down to e to the first power. Okay, and so, but those are y values, aren't they? Those are not x values, but those are my limits of integration from the lower one of e to the first power to the upper one, e to the second power, and all of this in between. Now, in order to do horizontal integration here, all of this needs to be in terms of y. So I need to switch this function around and do a little bit of algebra. X is equal to 12 over y. And so here, this function is going to be x is equal to 12 over y. My lower function right here is going to be x is equal to 0, obviously. Okay, this vertical line right here. And that helps me find out the area in between all of this. So we have 12 minus y minus 0. I don't really need that 0. dy. So this is kind of analogous to doing my vertical Riemann sums down to the x-axis, but this one is going to the y-axis. And so what is the integration of 12 over y? Would be 12 natural log of y, and we're going from e squared to e to the first power. And so we have 12 natural log of e squared minus 12 natural log of e to the first power. What's natural log of e squared is 2. 12 times 2 is 24, minus 12 ends up giving me an area of 12. So that area is 12 between these curves right here. And we looked at this horizontally. Let's take a look at another one horizontally. You can see how we could split this up. We're trying to find the area in between both of these curves here. So we're trying to find out this area. If I kind of do this like this, sound effects are not included. And I'm going to find the area in between all of these guys. Now, think of trying to find the area between this. We would have to split it up here. Now, that's difficult. How do we find the area of this function? We would have to take the total area. Then we got to split up into so many parts if we're going to go vertically. But we can go horizontally, can't we? We can go with little slices of this horizontally. Okay, and so my upper function would be over here. This is my upper function, which means the blue one would be my lower function. Kind of think of this, tilt your head 90 degrees to the right-hand side, and you'll kind of see it this way, which means we're going to go from this all the way over here down to here. You can see that this green one is the upper function all the way from -2 all the way to 3. So we're going to go -2 to 3 of this upper function. Now, can you see they already gave me this upper function in terms of y, which is really nice. When they give you functions in terms of y, you're usually going to do the integration in terms of y. minus, we have this blue function here, y squared plus y minus 1, d of y. And you can do this on your calculator, or you could do this in a longhand way. We end up getting an area of 125 over 3. And that is the area between these two curves. So I don't have to split it up vertically into a bunch of little parts. I can just do one full integral to find the area between these two curves when I look at it horizontally. I'm doing this in terms of y. My limits of integration is y equals -2 all the way to y equals 3. Then I have this y1 minus this y2, these two functions here, and I'm doing this in terms of dy. So hope this helped out. This was horizontal area between two curves.